Welcome, everyone. My name is Angie Balius. I'm a librarian here at Sims Library, and I'd like to welcome my friend and my partner in the Green Talk series, Alejandro Martinez. He's the Director of Sustainability here at Southeastern. He has some good news to share with us.
That's right, Miss Angie. So it's an honor to us as a Southeastern University and that we were named as a 2021 U.S. Department of Education Green Ribbon last week. We were one of the 5 universities who got this award this year, and it's an award like show the sustainability approach as a whole in the health, in the environment, in the education. So we're so excited that we got this award. Um, so yeah, it's part of what we have been doing for many years, and we have been doing the green talks too for 3 years, and promoting environmental literacy on campus and in our community. And today we have a really incredible topic to speak about, and we have Dr. Mark Benfield from LSU who is going to be discussing about the 2020 Nurdle spill on the Mississippi River. So we're going to get welcome to Dr. Benfield, and thank you so much for your time.
Thank you, and congratulations on the award, Alejandro. That's great.
I appreciate it.
All right, thanks for inviting me, Angie. So yeah, this is an interesting topic. I wish I didn't have to talk about it. I wish it had never happened, but it did, and it's been very interesting from a number of reasons, and there might actually have been a bit of a silver lining to this, which I'll talk about later. I'd like to acknowledge my co-authors. So in particular, one of your own, Dr. Liz Marchio, who's with the Vertebrate Museum, and then an undergraduate student in my lab, Kirsten Boswell, and Dr. M.A. Thomas at Loyola University, whose students have been very involved in this spill. Before I go on, I just want to give a shout out to Dr. Marchio. She is working for the Southeastern Louisiana University Vertebrate Museum. When I started working with her, she was working for the Parks Service down at Jean Lafitte National Park, where some of the spill occurred. But if you're not following Liz on Facebook, you're missing out on a lot of cool stuff that's going on at your vertebrate museum. So subscribe to that page, and you'll learn a lot of good stuff. So I want to start, you may have heard the term nurdles, maybe you haven't. What are nurdles? Well, nurdles are just raw plastic resin pellets. So they could be polyethylene, they could be polystyrene, they could be any number of different polymers. But before any plastic product can be made, whether it's the case for your cell phone or a part of a car or a Lego, it starts out as nurdles. So ethylene gas is converted into a polymer, and they usually make these nurdles as little beads or spheres or cylinders. And so this handful of nurdles here is just an example. And raw plastic resin pellets is another term that you might have heard. So why are they a problem? Well, part of their problem comes from their size and their abundance. Nurdles can range in size from the size that you saw there. Most nurdles for raw plastic resins are on the order of a few millimeters in diameter. But we also have a category of microplastics called microbeads. And so here are some microbeads that look like little mini nurdles that we extracted from the Mississippi River. And these are probably the result of plastics that are added to personal care products to act as an abrasive, an exfoliant, if you will. But just to give you an idea, look at the size of these things on the head of a penny. So let's talk a little bit about why they're a problem. And before we do that, I want to tell you a little bit about microplastics and where nurdles fit into the overall scheme of microplastics. So microplastics are operationally defined as any plastic that's 5 millimeters or smaller. So think standard Mardi Gras bead down to something that you might need an electron microscope to look at. And microplastics originate from a number of different sources. One of those sources is fragmentation of macroplastics. Although macroplastics, which would be anything bigger than 5 millimeters, plastics don't degrade in any short time frame. They take hundreds to thousands of years to break down. They do become brittle under the influence of ultraviolet light. So ultraviolet light causes chemical bonds in the plastics, particularly compounds called plasticizers. And you might have heard of some plasticizers like BPA. When you get a water bottle, you want a BPA-free water bottle, or phthalates. These are chemicals that kind of bind the polymers together to give them their texture, their flexibility, their stretchability or elasticity. Anyway, under ultraviolet light, these plasticizers start to break down and the plastics become brittle. And so then if you run over them with a car, if they get blown around in the wind or they're tumbled in the water, they will start to break into smaller and smaller pieces. So this piece of styrofoam in this picture is in the process of breaking into smaller chunks, which will then become microplastics. You can also get plastics that look kind of like nurdles introduced to the environment from bead blasting, which is like sand blasting, but instead of firing sand out with compressed air, you fire plastic powder out with compressed air, and this removes corrosion and rust and coatings from metals usually. Spillages of nurdles, when nurdles are transported from the moment they're manufactured to the time they're used, they get spilled. It's just the nature of the way they handle these things. They often use bulk shipping to move them around, so they can spill out of rail cars, they can spill out of trucks, spill out of barges, and get into the water. Tire wear is another one. We think of tires as being rubber, but in fact they're mixtures of rubber and plastic polymers, and so when you lay a patch of rubber, you're laying a patch of microplastic. A big one is laundering of synthetic fabric. So a lot of the clothes that we wear are made of plastic. And so you know how much lint comes out in the dryer. Even more lint comes out in the wash cycle when the rinse cycle occurs. And so that water that gets pumped out of the washing machine is just loaded with fibers. And if you're washing a load of plastic clothing, then you're washing a lot of plastic fibers into the environment. I showed you those little microbeads. These are personal care products. It's illegal to introduce them to personal care products in the United States since about 2018. However, they can be in prescription products. You may still find legacy products on the shelves of resellers like dollar stores and things like that. And if you travel outside of the United States, you can still find these things. So that Neutrogena, there are all those little dots in there are polyethylene granules that are designed to help it remove dead skin cells. Paints and coatings are largely made of plastics now, so when paint flakes, it's really plastic that's flaking into the environment. So these are all the main sources of microplastics in the environment. And when we look at these things, their small size is part of the problem. The smaller an object gets, the larger its surface area is. And microplastics have a large surface area relative to their volume. You can see on this little nurdle here, these both came out of the Mississippi River, and this little fragment of a piece of plastic. You can see a couple things going on. You can see cracks and fissures forming, and so that increases the surface area. And these cracks just show you how this is becoming more and more brittle, and so this is going to shear off into smaller and smaller particles. This is a piece of styrofoam, a tiny piece of styrofoam. Maybe it was once a clamshell for a to-go container or a styrofoam cup. And look at the surface area on this. Well, surface area is important because of the surface chemistry of plastics. You're probably aware that if you put water on a piece of plastic, it beads up like this. That's because water is a polar molecule. It's got a net positive charge where the hydrogen atoms are and a net negative charge where the oxygen is. So it's got a positive end and a negative end, so it's polar. Plastics are not. They're non-polar, and that makes them hydrophobic or water repelling. But nonpolar surfaces are quite attractive to nonpolar molecules. So organic pollutants, pesticides, herbicides, polyaromatic hydrocarbons, things, DDT, PCBs, those sorts of things, stick onto the surface of plastics. And so that's where that surface area comes in, because the moment a piece of plastic gets into the water, although it's not necessarily toxic per se, it starts to have more and more of these organic pollutants stick onto its surface. And so these little plastics become a kind of an Uber for all these little nasty chemicals that are transported on the surface of the plastic. And so herein lies another problem, and that is their small size. These microplastic particles are the right size to be mistaken for food by small fish and invertebrates. And these are some pictures taken of plastic fibers that we isolated from the Gulf of Mexico, and the scale bars are 100 microns, so 1/10 of a millimeter. So these are really small. Well, these circles up here on the left, the things labeled D, these are diatoms. These are single-celled algae. And so these plastic particles are in the same size range as these single-celled algae. So they're the right size to be mistaken for food. This little thing labeled R is a single-celled amoeba, a radiolarian. So all of these little particle fibers and fragments, there's another diatom, these could be mistaken for natural food. But then you might ask yourself, why the heck would any self-respecting fish want to eat a piece of plastic that's covered in PCBs? Well, the problem is that once plastic enters the environment, it starts to be colonized by microbes. And some of these microbes start to secrete a compound called dimethyl sulfide. And dimethyl sulfide, you've all smelt it. It's the smell of the sea. It's that salty smell you get when you get near the ocean. It's produced naturally by some phytoplankton. Seabirds use dimethyl sulfide to locate patches of phytoplankton where there's likely to be small fish for them to feed on. And so it doesn't take too long for these little plastic particles to become covered in microbes that are producing DMS. And so they start to smell, and they're about the right size range to be mistaken for a natural food item. And so what are the implications of these microplastics in the marine environment? Well, the animals that eat plastic are going to feel full, and they're not going to eat as much, and there's no nutrition, so they're not going to grow very much. And so it's going to reduce growth and feeding. If there's enough of them, if they're big enough, they can block intestines. So we've seen these horrible pictures of whales that wash up on the coastline with their stomachs packed with plastic bags. As I mentioned, the plastics are not digestible, so there's, again, reduced growth. You're not getting nutrition for the same nutrition as you would for a volume of natural food. And then, of course, there's the effect of the toxicity from these adsorbed persistent organic pollutants, or POPs, which are not present in concentrations that are high enough to kill, but they are present in concentrations that can cause sublethal effects. They can alter behavior, physiology. We really don't understand that too well. It's an emerging area of research, but it's a potential problem. All right, so that in a nutshell is why we should care about nurdles and microplastics. So let's go back to the nurdles. So this is a picture that Dr. Marchio and I took down near the French Quarter after the spill. And that spill in New Orleans was the first event we've had that we know of here in Louisiana, but there have been other nurdle spills. So in Hong Kong, there was a huge spill of nurdles when during a storm, a number of containers loaded with polyethylene were washed into Hong Kong harbor, and they literally coated the shorelines to the point where it was like snow. And very little was done to clean them up until locals got upset about it. There's a lot of fish farms out there. There's a lot of fishing, and they went out and started cleaning these things up. In Durban, South Africa in 2017, several containers fell off a ship, and again, nurdles were spilt all over the place. And that was an interesting spill, which I'll come back to in a moment, because it provided us with some pieces to this puzzle that we couldn't quite figure out in our spill. And then the biggest one that we've probably had nationally is a Formosa Plastics. It's a Taiwanese plastics company. They built a plant at Point Comfort in Texas. And they had been discharging nurdles for about a decade into the environment, despite their permit not allowing them to discharge solid waste. And so local activists got involved, and there was finally they were taken to court, and they were forced to pay $50 million in the settlement. The federal judge ruled that the company had violated its state-issued permits and the Federal Clean Water Act over the discharge of pollutants, and that it had been in violation of its permit since 2016, and that the violations are enormous. And the only reason they managed to hit them under the Clean Water Act was that just the amount of nurdles that the quantities they discharged were so enormous and so repeated that it just showed a flagrant disregard for the law. And so here you can see in this picture attempts to clean these nurdles up, and they're basically pressure washing the shoreline. And so that destroys all the vegetation and the life that's living along the shoreline of this creek. And it really has just led to gross negligence and pollution along Lavaca Bay. As part of that settlement, they had to put money towards research, and that gave rise to a group called Nurdle Patrol that I'll talk about later on. All right, so let's talk about our spill. So on August 2nd, 2020, the motor vessel CMA CGM Bianca, the company is a French shipping firm, CMA CGM. They operate these ships that transport shipping containers. It broke loose from its moorings during a storm. It was a freak wind, a microburst, and the cranes got pulled, several cranes got pulled into the water, and 4 shipping containers, 40-foot shipping containers, also entered the river. 3 of those containers were empty, but 1 was filled with polyethylene nurdles, and all or part of the contents entered the Mississippi River. So how much was lost? Well, CMA CGM wouldn't say, and the U.S. Coast Guard and the Department of Environmental Quality didn't know. So the moment that the Coast Guard got there, and this was what we call a major maritime incident because of the damage to the cranes, it was like over $10 million in damage, everyone lawyered up and they wouldn't talk. And so no one really knew how many nurdles had spilled. So we had to try and figure that out. So back to the Durban spill. In Durban, 2 40-foot shipping containers filled with high-density and low-density polyethylene nurdles fell into Durban Harbor. And those nurdles were packed in 25-kilogram sacks. Well, it turns out so were the nurdles lost in the New Orleans spill. We know that because we recovered several sacks intact, and they're labeled with Dow. They are polyethylene nurdles, high density. There's actually a sign on here that says, "Do not spill into any waterway." And so we know that these were packed the same way. They just jammed as many of these 25-kilogram plastic bags of nurdles into the shipping container. How many bags can you put in there? Again, from the Durban spill, we know that you can fit 990 sacks per container. So we can do some simple math. We know that 990 sacks times 25 kilograms gives us 24.75 metric tons, or 24,750,000 grams. We know the average weight of the nurdles because I took these intact sacks and took out over 100 nurdles and weighed every one. The average mass is 0.033 grams. So if we divide that in there, you get, it's about 743 million nurdles, call it 750 million nurdles. So that's our assumption, that the majority of the contents of the container were in fact lost into the river. So this was a substantial spill. This occurred on the 2nd of August, but nothing was done about it. Nobody said anything. And it wasn't until about a week later that someone started taking pictures of this situation on the sand spit just upriver from the Governor Nichols Wharf. So this is kind of just a little bit downriver from Cafe Du Monde in New Orleans. And you can see that just the vast quantity of nurdles that are covering the shoreline here. To give you a little perspective, this is underneath Governor Nichols Wharf, and this is just a little video that I took, slowed it down, and just walking along the river, you can see all of these little polyethylene nurdles along the shoreline. This is an outline of a 1 foot by 1 foot quadrat, and so just look at all the nurdles that are in here. Again, this is under Governor Nichols Wharf. So a really substantial spill. So where did they go? Well, they're buoyant. The majority of them likely stayed in the river and entered the Gulf of Mexico fairly shortly after the spill, within a few days. But large quantities were deposited along the shoreline downstream of the Crescent City Connection Bridge. I'll show you where the spill occurred in a moment. And so our approach has been to use quadrats, either 1 foot by 1 foot or 2 foot by 2 foot, to lay them out randomly and collect samples and try and figure out how many nurdles are present per square meter. We can scale up from 1 square foot to 1 square meter. And then if we know the area of shoreline affected by measuring with a tape measure or from remote sensing, we can estimate the total number of nurdles at each of these sites. So just to show you the complexity of this, and it was really a nasty sampling problem, very dirty area to work in. These are bottles of, we presume, urine that were rolling around there. You can just see the complexity of all the wood and debris with all these nurdles mixed in here. In some cases, just solid carpets of nurdles that were inches deep. So the spill occurred somewhere up here at the Ports America facility on the left side of the screen. And then we've been sampling at the Harvey locks, across at a site here, at just a number of places where there was accessible shoreline all the way down the river as far as the Belle Chase Ferry. And so I'm going to be showing you some data from the Chalmette Battlefield, which is over here by Jean Lafitte Park, over by Governor Nichols Wharf over here as well. So the approach was to go out and collect quadrats at each of these sites, take them back and dry the samples to get all the water out, and then sort through the samples to remove everything that wasn't nurdles. And so we want to get the mean weight of the nurdles. We wanted to run the nurdles through a spectrometer to see what the polymer spectra looked like and have some reference spectra that we could use, calculate the densities per square meter, get the numbers and weights of other micro and that should be macro and microplastic, measure the overall area of contaminated shoreline, and then take our estimates of the mean density per square meter, multiplied by the area to get the total number of nurdles per site. Processing these samples is ongoing. It's really problematic. This is a fairly clean sample, and you can see one of my students sorting out the woody debris, the organic debris, seeds, pieces of wood, other plastics, and then other nurdles that don't appear to be from the spill, and I'll talk more about that in a moment. And then we're left with nurdles that are ready for counting, and we don't count thousands of nurdles one by one, but we would take 100 of them, weigh them, and then weigh the total sample weight, and we could estimate gravimetrically the number of nurdles that way, and it worked very accurately. If there was only a couple hundred nurdles, we would count them directly just with a click counter. So the sample processing is ongoing, and we've still got some really big samples that we have to work through, plus a lot of little samples that still have to be washed, cleaned, get all the sand and dirt off of them, and dried, and then counted. So let's take a look at some results. So this is near Governor Nichols Wharf. This is just near Cafe Du Monde. We've got the sampling date here. So we sampled there on the 14th of August. I remember the spill happened on the 2nd, so 12 days later, on the 15th, on the 20th, and on the 25th. And here's a drone picture I took. You can see the shadow of the drone here, but you can see all these nurdles along the shoreline. The error bars are 95% confidence intervals on the mean. The densities are pretty high. You know, we have densities up to over 100,000 nurdles per square meter. And, you know, if you fit an eyeball line, it looks like probably the densities were going down over time. If we go downstream a little bit to the Chalmette Battlefield Beach, this is by the park, you can see that the average densities are down. We were at over 100,000 further upriver. Now we're down to on the order of 10, maybe up as high as 20,000 per square meter. And you can see that over time, the numbers of nurdles are dropping. I remember during this time, we had several tropical storms. We had some very heavy rainfall events, and the river is tidal, and the river level was starting to rise. And so as the river rose, it would mobilize some of these nurdles and float them further down the river. And here's just some pictures of the nurdles in there. So what about an organized cleanup? Well, initially the spill was ignored by the Coast Guard, by the Port of New Orleans, by the company that spilled them, by the National Transportation Safety Board, and by the Louisiana Department of Environmental Quality. However, Once there's some publicity started, then some pressure began to be applied to these organizations. So here's a story that was put out by Julie Dermansky in an online forum called DSmog blog, a plastic spill in the Mississippi River, but no accountability in sight. On August 18th, Tristan Barek from the NOLA.com published an article, "No Cleanup Planned as Millions of Plastic Pellets Wash Up Along the Mississippi River and Flow to the Gulf." And then August 28th, Julie Dermansky published another piece, Pollution Scientist calls plastic pellet spill in the Mississippi River a Nurdle apocalypse. And there's Liz Marchio and myself underneath the Governor Nichols Wharf sampling Nurdles. So because of this media pressure, CMA-CGM got their insurance company to hire a Texas environmental contractor called United States Environmental Services to come and clean up the spill. And so what they tried to do, and it worked reasonably well on open sandy areas like Governor Nichols Wharf, is they used leaf blowers to blow the nurdles into the water. They would put a boom out into the water, and the nurdles would then wash against the boom, and then they'd get butterfly nets and scoop them up. They also went out with shovels and just shoveled dirt, wood, rocks, and nurdles into big plastic garbage bags. And of course, then they weighed these garbage bags and attributed the total weight to all the nurdles that they had removed, when the vast majority of the contents of these bags was nothing but wood and mud. But here's the complexity. When you spill these nurdles, this is a really difficult place to clean up. I mean, here you can see the rocks and the wood and the debris that these nurdles are all caught up in. Here we are down near Crescent Park, and it's all riprap shoreline. It's extremely difficult, if not, I would say impossible, to get the nurdles out of here. So in addition to this rather ineffectual government, it really wasn't mandated by anyone other than the company responding to pressure and maybe Department of Environmental Quality leaning on them a little bit. There was also a big citizens response. And so a Facebook group called the Greater New Orleans Plastic Pellet Cleanup Crew started out, and they got people, particularly beginning out at Algiers Point, they managed to get people out there to clean up. And they built their own little quadrats and put screens from Home Depot or Lowe's in there. And they were very effective at collecting large quantities of nurdles. And they actually created, I think, just a fantastic and unique barter economy. They would provide refreshments, anything from beer to sodas and snacks and candy, but the currency was nurdles. And so if you wanted to buy a can of Paradise Park beer, it cost you 400 nurdles. If you wanted to buy Pellegrino, it was 160 nurdles. So this was really innovative, and they were able to get a lot of nurdles collected, and a lot of those nurdles have been sent back to my lab so we can add them to the total. And they would organize events like the Nurdle Sweep. This is one on October 31st. Meet at the Chalmette Battlefield and head to the river and text Nurdle to this phone number for more information. So they were really good at mobilizing a lot of concerned people. All right, so I want to turn a little bit now to the nurdles themselves. So this is what they look like. These are pictures taken with a microscope from my lab. They're high density polyethylene, just like the bag says. Mean mass, 0.033 grams, ranging in a very narrow range from about 0.0323 to 0.0336 grams. They're cylindrical with one end of them flared, so almost like a little mushroom cap here. And they're convexed on the flared end with a slight dimple. And then on the other end, the narrow end, they're concave. And so we can make measurements. They're about 3¼ millimeters tall and about 4.78 millimeters at their widest point, and 4.32 millimeters at the sort of majority of midpoint of the nurdle. So we can run these nurdles through a spectrometer. I have a couple of instruments in my lab called Fourier transform infrared spectrometers. And what these do is they shine an infrared laser beam onto a unknown particle. And you'll see instruments like these in any crime lab. they're used to identify unknown compounds. And so if you can imagine along the x-axis, we've got different shades of infrared light from the laser. Every compound, no matter what it is going to absorb or reflect different colors or shades of or wavelengths of infrared light to different degrees, depending on their molecular structure. And so you can see with this nurdle, there's a very strong pair of absorption peaks here, just near about 2,900 wave numbers. And then there's some other peaks down here. And so what we did was we created some reference spectra that we could store in a library to compare other nurdles against our reference spectra. So I took 10 nurdles from one of the intact 25 kilogram sacks. And we also had another sack that had leaked, so water had gotten into it. So I took 10 nurdles from the sack that had become wet and dried them out. And we then got these FTIR spectra on this instrument, and we saved them as a library of 20 different reference spectra from the Bianca spill. All right. So this is, a bunch of the nurdles that we think are from the spill, and you can see there's quite a range of colors. Some of them are almost pure white. Some of them are kind of an olive brown. But if you look at the morphologies of the brownish olive colored nurdles, they look the same. They have the same dimensions and morphologies as the spill nurdles. So we believe these are all Dow nurdles. The question remains, though, were they all spilt at the same time? And that's we're not so sure about. But the discolored nurdles are morphologically consistent with the spill nurdles. If we run the spectra of these 9 discolored nurdles and these 9 sort of largely clean nurdles against our reference spectra, we get really high matches. So they appear to be the same polymers. We do, in fact, get a slightly higher average match. So if it was a perfect match, you'd get 100, but we don't get perfect matches. So the mean match for these discolored nurdles is 94.6%. The mean match for the cleaner nurdles is 97.2%. But these percent matches are not statistically different. So we can't say that these are a different group of nurdles. But we did find lots of other nurdles in the sample. And this is just from one sample. You can see some styrofoam down here. These are all other nurdles. So when I said there was a silver lining to this spill revealed chronic nurdle pollution along the Mississippi River at all of these sites that we sampled that we didn't know about. If we had not sampled, if these nurdles had not been spilled, we wouldn't have gone out there looking for them, and we wouldn't have known that in addition to these spill nurdles, there are in fact a lot of other nurdles that are being deposited along the banks of the Mississippi and being transported into the Gulf of Mexico. Just to take an example, here are 24 samples from below Crescent Park, taken on the 24th of September. Blue are spill nurdles based on morphology, and orange are other nurdles. And so other nurdles ranges from 0 to 25% of the sample numerically, with an average of almost 6% of the samples of the nurdles in any spill being other nurdles. And so now we've got another problem where we want to know where these other nurdles came from. I can tell you that I can tell you where I suspect they're from. They're from the petrochemical industry in that corridor between Baton Rouge and New Orleans, where there are many plants that produce nurdles. A couple of years ago, we did a sampling program in the Mississippi River, sampling between Baton Rouge and New Orleans. We had a station upriver of Baton Rouge, in Baton Rouge, and downstream from Baton Rouge. And then we had a station above New Orleans and below New Orleans. We didn't get many nurdles in Baton Rouge, but we got quite a few in New Orleans. So we knew the nurdles were likely coming from that petrochemical corridor, that chemical alley, if you will. So the question is, what are these nurdles and where are they coming from? And that has turned out to be a bit of a challenge. So we have some existing polymer libraries that came with the instrument. And so it can tell us, what kind of plastic we have. And then we have those 20 reference nurdle spill spectra. So here's an example where we have a Dow nurdle from the spill on the left, and we've got this other nurdle which is bigger. It's more oval, it's more transparent, and it's a different color. When we run it through the FTIR, we get the top match is a 92.02% match against a polymer called polyethylene propylene diene. The nearest match to our Dow references was only an 86.36% match. So the FTIR tells us it looks different and it is different. But here's a different case. Here's one, again, a Dow nurdle on the left and a different nurdle that's shaped more differently. It's kind of a medium yellow color, and it matches out as a Dow reference spectrum. The nearest match to any other polymer was an 84.57% match with polyethylene type F. So why is that? Well, it's just that it turns out that the closest match was this Dow reference match. We need to get library spectra for the source nurdles from each of these plants in order to be able to fingerprint them and be able to say where they came from. Otherwise, we're just going to get matches that say, yeah, they're Dow nurdles, which they aren't. Here's a case where we've got 4 nurdles. They are morphologically different from the Dow nurdles. They're similar, but they're different. This first one is a 92 to a 99.2% match for the Bianca nurdles. Nearest match is only 84% for polyethylene type F. We look at the second one, similar situation. Again, a high match for the spill nurdles, a low match for polyethylene type F. Situation here, and then the third one, the fourth one, the same situation. And the fourth one really looks different. If you look at the fourth one, this is from the lower 9th ward on the 22nd of September, and here's a Dow nurdle. I mean, this thing looks nothing like the Dow nurdle, but again, it's coming up simply because we don't have adequate reference libraries as a closest match to the Dow nurdles. So what do we need to do? We've got to go out and collect nurdles from these plants that are producing them and collect reference spectra. Now, if I show up at the gates or the corporate offices of one of these plants and say, hey, I'd like to get 100 of your nurdles so that we can get their spectra and see if they're the ones that are contaminating the shoreline, I think you all know what the answer is going to be. I'm going to be thrown out. So we're going to have to be clever about how we get these. We're either going to have to go and sample near the vicinity of the plants where they'll likely be abundant, or use some subterfuge to try and get some pretext to get the samples, but we're going to do that. I also went down to Elmer's Island, which is down near Grand Isle, to see if these things were showing up on the beaches, and when I got there, the dunes were just full of nurdles. And I thought, aha, they're already here. And they looked about the right size and color. However, when you start looking at these nurdles, they're different. They are pointed or convex on both ends, kind of sharply pointed on one end and convex rounded on the other end. And they have sort of a dimple in the middle. So they're not the same nurdles. So we went out there looking for the Bianca spill nurdles, and we discovered evidence of yet another spill that had occurred and contaminated the beaches sometime prior, and we don't know where those nurdles came from. They could have been dumped from a ship. We just don't know. Or spilled. I'm not alleging that they were intentionally dumped. So we've got lots of nurdles and from other sources that have high spectral matches to the spill nurdles, despite subtly or grossly dissimilar morphologies. And these nurdles that we got off of the Elmer's Island samples, again, had the highest spectral match was to the Dow reference spill nurdles. So they're also high density polyethylene, but they're not from the spill. So our future work, we want to obtain samples of pure nurdles from these other manufacturers in the chemical corridor. We want to create library spectra for these nurdles. And then we want to work more on weathering. What happens to these nurdles over time? Remember, the discolored ones had a lower match. We know that they're going to start to absorb different organic pollutants. We know that ultraviolet can start to affect them. And so Dr. Thomas, my co-author, had her students expose them to high intensity ultraviolet light. And we did see a reduction in the percent matches over time. So we need to do more weathering impact, because if we recover a nurdle that's been out for a year, even if it came from the spill, we need to understand how its spectra might change over time. So what can you do? Well, you can join Nurdle Patrol. So Nurdle Patrol was started with funds from the settlement in Texas, and it began in Texas, but it is expanded all over North America. It's run by a scientist at the University of Texas named Jace Tunnel, and I'll play you this short video about Nurdle Patrol.
This is a nurdle, a tiny plastic pellet used to make. Millions of nurdles are spilled at the factory or in transport, and they're washing up on our beaches. They are dangerous to marine life, so we need your help tracking where they wash up on our beaches and bays. Join the Nurdle Patrol. As a citizen scientist, you can help put a stop to this harmful plastic pollution. Go to nurdlepatrol.org and learn how you can conduct your own scientific survey. It's easy and anyone can do it. Your data, combined with thousands of other surveys, is more than a research project. It's a potential solution. You can make a difference. Join the Nurdle Patrol. Go to nurdlepatrol.org.
So I highly encourage people, and if you think that you're not going to find nurdles in your neighborhood, I think you'd be surprised. We recently did some sampling in stormwater canals in Baton Rouge, and our graduate students went through every item that we recovered from this canal, and we found a bunch of nurdles. And so we don't have any nurdle plants in the neighborhoods that feed the stormwater canal, but we do have railroad tracks. And I know in Hammond, there's a big railroad track that runs right through town. And so start looking along your railroad tracks, because if nurdles are shipped on those tracks, they're going to be there. All right. The other thing you can do is download a free app and start doing litter surveys. They can include nurdles and other things. So we have a new initiative called the Mississippi River Plastic Pollution Initiative. It kicked off the 1st of this month, and here's a short promo for it.
The Mississippi River flows over 2,000 miles through the heartland of America, from its headwaters in Minnesota to the Gulf of Mexico. This river is the watershed for 32 states, and we are impacting it with our actions. The litter that we produce from coffee cups to masks or plastic bags can end up in the environment, making their way to our rivers and then into the oceans. Globally, this results in about a dump truck's worth of plastic entering our ocean every minute. The Mississippi River drains 40% of the continental United States, creating a conduit for our litter to reach the Gulf of Mexico. In September 2018, the mayors of the Mississippi River made a commitment to reduce plastic waste in the Mississippi River Valley. To support that commitment, the Mississippi River Plastic Pollution Initiative is working with volunteer citizen scientists, local communities, associations, and researchers to collect data to understand the magnitude of the plastics problem along the Mississippi River. Scientists need data on what's ending up in the environment so that we can use that information to address this important environmental problem. And you can be a part of the solution. Download the free Marine Debris Tracker app and choose the list entitled MRCTI to collect data on what plastic pollution looks like in your community. The data will be analyzed to help us understand the problem, which then leads to solutions that will help policymakers, businesses, and citizens alike take action. Join us today to ensure a clean river and clean seas for all.
So with that, I'm going to stop. I want to acknowledge Scott Eustace with Healthy Gulf, who's really been very committed to helping to understand this problem. Jace Tunnel with Nurdle Patrol, Julie Dermansky, Kimberly Cook, students in my lab, Sophia Lingo, Nicole Nguyen, and the GNO plastic pellet cleanup crew, who really just were heroes in this whole thing. So I'll stop there, and I'll be happy to take any questions. Thanks.
Well, thank you so much for all the information. It's kind of like overwhelming to see some of these things happen, and you know, it's sad to see like when this happened, like it was not too much coverage for the news, and you know, it was not too much action. Like it was happening. I was looking at the days. It was also when Corona was happening, but it should not be an excuse, no, to keep the area clean and do events. So thank you so much, and yeah, let's go for the questions. And I was just looking here at the app before we go. Is the Marine Debris Tracker app.
Correct.
to check out. So I'm just looking at that right now.
Yeah, so that's available for iOS and for Android. One other thing I want to say is there is a resolution, it may be become a bill that's making its way through the legislature this year, which would ban the release of pre-production plastic pellets. So it's in response to the spill. I don't know whether it's even going to make it out of committee, but there is some attempt to do that. And the other point I wanted to make that I guess I should have made earlier on is that these pellets are not considered toxic, and so that's why they're not governed by the Clean Water Act. But if they use them to make a lot of items, for example, shopping bags, disposable plastic shopping bags. So if you weigh a plastic shopping bag from Albertsons, it's the equivalent of about, I think 71 of these pellets. And so if you take 740 million and divide by 70, you're over a million, about over 10 million shopping bags. If I took 10 million shopping bags and dumped them into the Mississippi River at the French Quarter, someone would stop me, and you better believe I'd get in trouble. Some activists trying to raise awareness about the Formosa plant that's projected to be built in St. James Parish left some Ziploc bags of nurdles on the doors of legislatures, and they were charged with environmental terrorism. So, these things, they're considered highly dangerous if they're dropped on someone's doorstep, but if you put millions of them in the river, not a problem.
I'm concerned about the inconsistent response from state and local officials, and why it took a couple weeks to really begin a serious cleanup effort. And are we going to have to rely on people like ourselves who are concerned about this to do all the monitoring?
Yeah, until these things are regulated as pollutants, and until there's legislation that has some teeth to it to mandate a response, then we're not going to be able to. We're going to be on our own. Yeah, it is a real problem, and that needs to change.